Okay. So now we have a way to access the individual frames, which may be handy. We may need that. We have the possibility to start the animation. We have a possibility to stop the animation. But the animation itself doesn't really do anything because in the update method, there's no logic. So let's see how we can actually implement this. So first of all, what we need to do in the stop method, obviously, when we stop the animation, we need to set the playback progress back to 0. Like this. Yeah. And let me think. Okay, so in the update method, first of all, what we need to do is check if the animation is playing, and if so, we need to increase the playback progress. So let's here check if is playing. We need to do stuff. If it's not playing, we don't really need to do anything. So if it is playing, playback progress, whoops, we need to increase the playback progress by the time that has passed, and we can get that value from the game time instance here. So there's an elapsed game time property here, and there's a property in that called total seconds, but that's actually a double, and a double has a higher precision than a float. Our playback progress property is of type float. So this cannot be implicitly cast to a float, and therefore we need to explicitly do that by using the explicit cast operator like this. So we will get the total number of seconds that have passed within this frame, and increase the playback progress property by this value. And that should be fine. So now, let's see. Obviously, we need to we need to be able to tell from the outside which one is the current sprite that should be rendered. Yeah, I mean, or what else? Let me see. Yeah, we need a way. Let's go back into this beautifully drawn timeline here. So let's say our animation has been updated a couple times, it has been playing, and it's now at its third frame, so the frame with the index 2. We're now here in the timeline. This is the playback progress. Playback. Beautiful. So we're now here in the timeline, and from the outside of the class, we need to be able to tell. So we do know the playback progress, but we don't know which frame should be drawn now. So we need to be able to tell, to somehow determine which frame should be drawn. So let's do that. Let's go ahead, go in the code, and add a new method. Sprite animation frame, and call it get current frame, for example. We could also implement this as a property, but let's implement it as a method. Get current frame. Actually, let's implement it as a property. I think that's actually more appropriate. So call it current frame, and it will only have a getter and not a setter, because it's the getter will have logic, so this is not, doesn't return the value of some field or something. It will actually calculate the return value. And in the getter of this property, we need to check what the current sprite animation frame would be. And let's see. We do have the current playback progress, and all of the frames have a timestamp, and by that we should be able to tell which frame is currently active, should be drawn, it should be returned. So let's say, like I said, let's say we here, in that case we would need to return the third frame, so the frame with index number 2. And basically these here are the actual time stamps of the frames. So what we would have to do is first order the frames by their timestamp in an ascending manner, and then let me just put this in code here. Frames order by. Order by is an extension method from the LINQ namespace, so we need to add a using directive here, system LINQ. And with order by, we can order the list of frames by a specific property. Let's order them by the timestamp. And this will return a new enumeration that is actually ordered. And then we can, from that enumeration, let's see. Or do we actually need to order them? Really what we need to do is find the frame in the list we need to, actually, what we need to do, this is our playback progress value. We need to return all the frames, or we need to look for all the frames that have a timestamp value that is less than or equal to our playback progress value, and then take the one with the highest timestamp value from that, right? So in that case, if we, in our first step, here we have the playback progress value, and in our first step we would get all of the frames with a timestamp less or equal to this value, which would be these three timestamps. We would return these 3 frames, and then from that collection we would simply use the one with the highest timestamp value, which would be the 3rd frame, and then we would be good, right? So let's do that. So we don't actually need to order them. Actually, we can put this in a very simple expression. We can just say return frames where, which is also from the LINQ namespace, timestamp less than or equal to playback progress. And from that get the first one where the timestamp is the highest. But that would cause a problem if there are no frames in the animation. But let's just, for now. Oh no, actually, hold on. Okay. Get all of the frames where the timestamp is less than or equal to the playground progress, then order them by the timestamp. So we were actually correct with that. And then from that, use the last one. But let's make it actually say last or default, because there might not be any frames in this animation. So let's break this up and actually make this, put this into a couple of lines like this. So from the frames, take the ones, or query the ones which have a timestamp value less than or equal to the current playground progress, order them by the timestamp in ascending order. So it goes from the lowest value to the highest value. So the highest value would be the last one. And then we just simply use this last or default extension method from LINQ, which returns the last one in the enumeration. So this would then actually return the target frame. And we use last or default instead of last, because last or default, in case there is no element in the collection that doesn't match the predicate, the condition, then it would return the default value for the target type. The target type in this case would be Sprite Animation frame, and the default value for that would be null. So if there are no frames in this animation, then this would simply return null. Yeah, this should be fine. And this here, I don't know if you're familiar with that. This is a lambda expression, and it's a form of a anonymous method. So the where extension method takes a delegate for its parameter, and a delegate is basically a data type that encapsulates a pointer to one or more methods that match a certain signature. So really what we do here, this is basically a function. It says, it puts, this is the parameter of the function, and this would be of the type Sprite Animation frame, and it would evaluate this function basically for each element in the sequence, in the collection. So it would iterate over the frames and use this function to determine if this condition is met. So would pass the first element here, and then evaluate this expression here and say, check if the timestamp property of the first element is less than or equal to the progress, and if so, included in the returned collection, and if not, obviously not included. And then proceed with to the second element in the collection and do the same thing. And then order them by the timestamp and then get the last one. So this should be fine. We could actually include a draw method here, or we can have the caller or the user, the client of this class, just simply get the current frame and then from there get the current sprite and draw it. Now let's actually implement a draw method that also takes a sprite batch, which is in a different namespace that we have to reference. So I just added this using directive. And using the sprite batch, we will then simply say, first of all, say declare a local variable of type Sprite Animation Frame, call it frame, which would be equal to the current frame. And like I said, this could be null if there are no frames. So, and then we could say if frame does not equal null, then we would do frame sprite draw. And obviously we needed position here. So, like this. So this way, we can simply, when we have an instance of our sprite animation, we can simply call the draw method, pass a sprite badge that should be used for rendering and a position, and then it would automatically look up the current frame that should be drawn, and if there is one, draw it to the screen or to the sprite badge. Yeah, okay, let's see what else. Well, right. Okay, so the playback progress here, it increases indefinitely, so it would just go on forever. But obviously the timeline has a start and an end, right? So in our case, actually, let's complete this here. We only have these timestamp values to make up the length of our animation. So let's say there's only 2 frames. Well, actually, let's just go with this example as it is here. So we have 4 frames in the animation. How would we calculate the length of this animation? This way, it cannot really be done, because we only know when the frames start, but we don't know how long a frame will last. So even if we took the highest or the greatest timestamp here, it would only give us the start of the last frame, but we still don't know how long the actual animation is. What we could do to remedy that is to have the user of the class basically pass a dummy frame here, which would not have any length whatsoever. It's just a keyframe that indicates the end of the animation. So that way you would actually have 5 frames, but the last one doesn't really, it's only to indicate the end of the animation. So let's go with that. So what I mean by that is that if we do that, we can determine the length of the animation by simply returning, simply using the highest timestamp value, the greatest timestamp value. So let's do that. Let's keep it simple. Float and say length or duration. Let's use an expression body here, and it will return actually, let's do it like this. If there are no frames, the duration is obviously 0. If frames count return 0. You could also do if frames not any, like this. Any is another extension method from LINQ. It has 2 overloads. If you don't pass anything, it will simply return true if there are any elements in the collection. And we can negate that to check if the collection is empty. So if frames does not contain any elements, then we simply return 0. Otherwise, we return the highest timestamp value using this max extension method from LINQ as well. So it will iterate over the frames, check the timestamp value, and return the highest, the greatest value. And if we use a dummy keyframe here as the 5th frame in this case, this would then actually indicate or determine the actual length, actual duration of the animation. I hope this is clear. If not, let me know. You can ask questions and add any comments in the comment section, of course. Okay, so let's go ahead. We have a way to determine the duration. So that way we can now check if our playback progress, as if it is higher than the actual duration of the animation, we need to reset it. So let's go ahead. If playback progress is greater than duration, we need to decrease the progress by the duration. So that means, so this is timeline is 2 seconds long. So, but let's say a frame has passed and now we're here, which is, I don't know, 2.1 seconds. And we would simply then subtract the 2 seconds, which is the entire timeline, which would put us back somewhere around here. So that way we would have implemented an infinite loop. And since all of our animations are looped, actually, they don't just play once and then stop, this would be a fitting solution. So let's go back into Visual Studio. This should actually work. And we can test that. Let's remove this empty line here. I think we're good. Okay. So let's test this, and in order to test this, we need to determine in our sprite sheet here what makes up the animation, the blinking animation. And it seems to consist of only these two sprites, obviously. The blinking one is right next to the idle one. So let's go ahead and go into our T-Rex class. And here we can add a new field of type Sprite Animation. Call it idle animation. Oh. And in our constructor, actually assign a new instance of Sprite Animation to that field. And then we need to add frames to that Sprite Animation. The first frame would be what is currently our sprite property here. So this one. So let's actually remove this line. Let's copy this and remove this line entirely. And here say idle animation, add frame. Then here pass a new sprite, which I just copied, so I can just paste it. So here pass the sprite and the timestamp. And yeah, obviously the first frame would start at 0 seconds, so let's just pass 0. And then add another frame to the animation, add frame, new sprite. Texture is the sprite sheet. X would be this value plus the width. So the starting point here plus the width of the sprite would give us the position of this next sprite. And the Y value would also be 0, so simply pass the same value here. And the width is the same as well, I think. So again, default sprite width and default sprite height. Okay, so now we have an animation with 2 frames. Oh, we need to pass a timestamp, of course. That's the second parameter. Yeah, now we need to know at what timestamp the second frame would be triggered. And let's assume that this animation is played at something like this. So this would then mean this is a 20 FPS animation. But we would also have to add a keyframe to indicate the end of the animation. So let's add another frame, which is completely identical to the first frame, but has a different timestamp, which would be 1 divided by 20 times 2. Should be fine. And then I think we can actually directly say the animation should play. And I'm not sure anymore if we even need this sprite property, since we now have an animation property. Let's remove this for now. Okay, we don't really need it anymore. And here, instead of saying sprite draw, we will say if the state is idle, we say idle animation draw, pass the sprite branch and the position. But what we also need to do is update the animation. So in the update method of our T-Rex class, say if the state equals idle, idle animation dot update and pass the game time. Okay, now we just need to make sure in our T-Rex runner game class here to actually call the update method of the T-Rex so that it is regularly updated. So here we say T-Rex update, pass the game time as well, and there we go. And now here in our draw method, we still call the draw method of our T-Rex, and our T-Rex will then in turn check if it is in idle state here, and if so, call the draw method of the idle animation. And in the update method, actually update the idle animation. And I think we're good. I think this should work. Let's see. Let's see if we forgot something. Oh yeah, so now it's blinking, but it's blinking rather rapidly. Now why is that? Obviously we said, okay, I didn't think this through. So we can't have our idle animation just play the entire time. I mean, it's correct, it keeps playing, but we don't want the T-Rex to keep blinking. I mean, it does play the animation correct, but we don't want the sprite animation to keep playing and keep the blink animation to keep playing while the T-Rex is in idle state. So instead, we want to randomly, in random time intervals, play this animation. So let's see. How can we implement this? Let's actually not call this idle animation because it's somewhat misleading. Let's call it blink animation. And I just changed this by using a refactoring tool that Visual Studio provides. I just right-clicked it and said rename, and it will rename all of the references of this field then. So yeah, it's actually working. It just doesn't make sense the way we handle it right now, because we just keep playing this animation over and over, and obviously that causes our T-Rex to blink like he's crazy. So actually in this instance we have an animation that shouldn't be looped over and over. We just want to play it once. So maybe we do need to implement the ability to have an animation that only plays once. Let's see. Yeah, so this is what happens when you don't have any script, whatever, no preparation, but that's fine. Let's solve this problem. So first of all, the blink animation should only play once. So that means in our animation class, let's add a property of type bool and call it should loop. And by default, it will be true. And then in our update method here, we need to check here if the playback progress is greater than the duration. That is still correct. And it should loop, then it should be reset. Otherwise, it should simply stop. And this should be okay. So now, should loop is by default set to true. In this case, we don't want that. So here, in our T-Rex class, in the constructor, here we can say blink animation should loop equals false. And we can even simplify that using the object initializer syntax, which Visual Studio actually suggests here, like this. It's really a matter of taste. Let's go back to this syntax, and yeah, we don't actually want to directly play it. Let's do it as I suggested first. Construct the animation randomly. So let's go ahead and let's implement a new method, which will be private. It will not be, you cannot call it from the outside. It will return a sprite animation, and let's call it create blink animation. And let's first of all copy all of this code here into this new method. And then instead of hard coding these timestamp values, the first frame obviously will be at timestamp 0 seconds, which is correct. And then the one with the blinking eye will be at a random time stamp. So let's use the random class to generate a random timestamp value. Hold on. Whoops. First of all, create a new field of type random, and in the constructor actually create a new instance of random, and then we can use this field to generate random values. And then here we could say blink timestamp equals random next double. It will generate a value between 0 and 1, and we can simply multiply that by our maximum value that we want to generate. So first of all, multiply this by 10, the maximum value, and then we need to subtract the minimum value, which we said is 2, and then it doesn't really matter, like this. But this returns a double. Let's actually store this as a double, like this. And obviously these hard-coded values should be constants, but let's keep this for now. Yeah, so what this does, next double returns a value between 0 and 1, like I said, a decimal value. It will then multiply it by 10 minus 2, or should it be plus? No, that's fine. 10 minus 2, so it will give a value between 0 and 8, and then it will, since 2 is the minimum value, add 2, so that way it would give us a value between 2 and 10. So let's make this into a constant now. We can simply right-click here, say quick actions, introduce constants, or we can say introduce constant for all occurrences, which would be these two. That's fine. And say LINQ animation random min, and the other one should be LINQ animation random max. And we can play with these values later, adjust them a little bit, but let's just keep it like this for now. And obviously here we don't have a reference to this local variable sprite sheet from the constructor, and actually it doesn't make sense to create new instances of Sprite each time that we create a new animation. We can reuse the same sprites every time we create a new animation. Let's create two fields. One named idle sprite and one named idle blink sprite. Okay. Yeah. So then here in the constructor we will create these sprites, and for that we will just, let's copy this entire block for now. Here. And obviously we don't need this. Remove. What did I just do? There. And remove this. And assign this new sprite to idle sprite. And this sprite we will assign to idle blink sprite. Like this. And obviously this needs to be removed. Okay, so now in the constructor, whoops. So now in the constructor we instantiate these two sprites using the sprite sheet that was passed to the constructor, and we store them in a field so we can use them later. And then in our create blink animation method, we will simply here pass the sprites that we just created, idle sprite for the first frame, and for the second frame we will pass the idle blink sprite. And then for the third frame, which is really just the indicator for the end of the animation, we will pass the idle sprite again. We could also pass the idle blink sprite, it doesn't really matter because it's the end of the animation anyway. But yeah. And here, instead of passing 1 divided by 20, we will pass the blink timestamp. So the second, and we will, of course, cast it to a float, because that's the type that the method expects. So now, instead of hard coding the value, the timestamp for the second frame, we will use a random value between 2 and 10. And here, the last frame should really be the blink timestamp plus some time that the blink itself should last for. So let's say the actual the T-Rex should close its eyes for I don't know, 2 seconds maybe, so it's actually visible. 2 seconds may be too long, maybe 1 second here. I don't think we need to define a constant for that. Let's just hard code it here as 1 second. And yeah, and obviously we need to return here the blink animation. Actually, we don't need to return anything. We will just store it in a field. Yeah, this should be fine. So now, if it's in idle state, update the blink animation, and if the blink animation is no longer playing, which will only be the case if it is if it's done, we will call the create blink animation method to create a new one. Let's actually add braces here. Create a new blink animation, which will then play. Let's actually do this first. Like this. Okay, let's see. So in our update method, we first check if the T-Rex is in idle state. If that is true, we will also check if the blink animation is playing. Is not playing. There we go. If it is not playing, we will create a blink animation and send it to and call the play method to make it play, and then update it. And we know that it will, as soon as it finished, since it is not a looping animation, it will no longer be playing. So the isPlay property will return false. And as soon as this is false, it will create call the create blink animation method again and play the animation, update it again. And the timestamp for the second frame will always be completely random. So this should now work. Let's see. Oh, I made a mistake. Oh, right. Of course. There is no blink animation. In the first update interval, when the update method is first called, blink animation has not been assigned yet. So we need to assign that. So we need to make sure it has a value once the T-Rex object is constructed. So in the constructor, we simply call the create blink animation method like this. First of all, let's call the play method here as well. So create a blink animation, then play the blink animation, and then the update method will be called. Check if it's idle. If it's not playing, create a new animation and play it, then update it. It should be fine. Let's go into the animation again. If playback progress. Oh, yeah. Sorry for that. I messed this up. This is really stupid. Okay, so we check if the playback progress is greater than the duration, and it should loop. Then basically subtract the duration to reset it. But in the else branch, we call stop if either of these two conditions is false. So when the animation starts, obviously the playback progress will not be greater than the duration, and this would automatically cause the else branch to be executed, and this will call the stop method. So yeah, it will stop all the time. So that's obviously stupid. So let's add some braces here to the if block here, and then instead here if playback, then here if it should loop, then do this, and else stop. So obviously it should only stop if the duration of the animation is reached or is exceeded. So yeah, that was pretty dumb, but yeah, you know, it happens. Yeah, so now it works. The blink time is a little bit too long. It blinks for an entire second, which seems to be too much. Yeah, let's actually make the actual blink animation a little bit shorter. So let's go back into the T-Rex class and actually make this here a constant and call it blink animation eye close time or something like that. So the eye will be closed for half a second. That should do. Let's run it again. Yeah, that looks better. Okay, perfect. So now animations are working, and yeah, perfect. Okay.